Welcome back to our Machine Learning Essentials series. We've covered all the core theory. Now, it's time to get our hands on our very first algorithm, the simple, powerful, and fundamental linear regression. So, what is linear regression? It's a supervised learning algorithm used for regression tasks, that is, predicting a continuous numerical value. Its goal is incredibly simple: to find the single straight line that best represents the relationship between an input feature and an output value. Imagine you have data on houses, their size in square feet on the x-axis, and their selling price on the y-axis. If you plot this data, you'll see a cloud of points. Linear regression's job is to draw the one straight line that cuts through this cloud as accurately as possible. We can then use this line to predict the price of a new house just by knowing its size. The model itself is just the classic equation for a line you learned in school: y equals mx plus b. In machine learning, we just use different letters. We say the predicted value, y, is equal to a weight, w, times our input, x, plus a bias, b. The entire learning process is just about the algorithm finding the perfect values for w and b that make the line fit the data best. And how does it find these perfect values? Using the exact tools we've already learned. First, it uses a loss function, typically mean squared error, to measure how far away the line's predictions are from the real data points. Then, it uses gradient descent to slightly adjust the weight and bias, the slope and intercept, to make that error a little bit smaller. It repeats this process over and over, nudging the line into the best possible position. Despite its simplicity, linear regression is used everywhere. It's used in finance to model the relationship between a stock's price and economic indicators, in business to forecast future sales based on marketing spend, and in science to estimate the effect of one variable on another. And that's your first full algorithm. Linear regression is a transparent, powerful, and essential tool. But it can only predict numbers. What if we want to predict a category, like yes or no? For that, we need a different tool. Join me in the next lesson as we adapt this core idea to solve classification problems with logistic regression.